Okay, welcome back to the Art Hazards Toxicology module. This is part 7. We'll be talking about other chemical hazards besides just toxicity. Now, if we go back to our hierarchy of chemical protection that we've talked about, the top one is not using toxic stuff. The next one is using less hazardous stuff, not just less toxic stuff. Because toxicity is not the only art hazard that's out there. There are a lot of other physical hazards that we need to be careful of. Here's 3 examples: things that are corrosive, things that are oxidizers, and things that are flammable. Corrosives includes acids, mordants, and bases. These are things that will burn your skin and eyes on contact. Look for that corrosive symbol, and that lets you know that you should be wearing personal protective equipment to keep that stuff from coming in contact with you. But you also need to be really careful that you don't breathe in any vapors that are released from this stuff, because they will burn your lungs and your mucous membranes in your eyes and elsewhere. And these corrosive materials are used in a wide variety of art products. So many different art disciplines will use these. One of the primary places we find it is in printmaking. In printmaking, we're etching metals, and so we'll find 3 acids in particular being used: ferric chloride to etch copper plates, hydrochloric acid for steel plates, and nitric acid for zinc plates. The ferric chloride will burn your skin and eyes on contact, but it's not particularly volatile. Hydrochloric acid burns your skin and eyes, but because it releases vapors that can be inhaled, it can also burn your lungs. And then nitric acid is just bad news from a variety of different ways. It burns your skin, burns your eyes, burns your lungs. It's also a powerful oxidizer that can react to flammable materials and also causes it to break down its bottles, and it's also quite toxic. As far as flammables and combustibles go, these are things that can produce vapors that can ignite at ambient room temperatures. For flammables, combustibles would ignite if they're heated a bit more. So how flammable is your product? How can you figure that out? What you really want to do is you want to look at a material safety data sheet. So type in the name of your product with the letters MSDS afterwards in any search engine, and then you'll get a bunch of places you can go. In this case, I found a material safety data sheet, and I opened it up, and now there's a whole bunch of information. So how do I figure out what to look for? Well, go to section 4, and that's the fire and explosion hazard data, and look for the flash point. That's the temperature where flammable vapors will be released once it gets heated up to that point. So in the case of this product, our dye, it's 60 degrees Fahrenheit. The lower the temperature, the more easily this stuff can be ignited. So acetone, which is incredibly flammable, has a flash point of 19 degrees below 0 Fahrenheit. Lacquer thinners, 24 degrees above 0. Odorless thinner, 110 degrees. Citrus solvent, 127 degrees. And biodiesel is greater than 266 degrees. Not very flammable. So if you're looking for something that poses less of a fire hazard in your studio, look for something with a higher temperature flash point, which means you need to warm it up to, in the case of citrus solvent, 127 degrees before any flammable vapors will be coming off. And then the last one are oxidizers. These are things that promote burning. If they come in contact with flammable liquids, they can actually cause them to ignite. Some of the oxidizers we find in art are the photographic intensifiers, like the dichromates and the permanganates and the persulfates, and the patinas that we find in some sculpture work, copper nitrate, ferric nitrate, and nitric acid. For more information about art chemical hazards, search either Google or YouTube for King County art hazards. If you have questions, send an email to me, Dave Waddell, at haz.waste@kingcounty.gov.